Hi students, welcome to our YouTube channel. Today we are going to solve some problems regarding net reaction enthalpies. So our topic is using Hess laws to calculate net reaction enthalpy. Okay, the question is nitric oxide can be formed from nitrogen, hydrogen and oxygen in two steps. In the first step, nitrogen and hydrogen react to form ammonia. You can see here the equation is given and the del H is equal to negative 92.0 kilojoule. Okay, that is over the first point. Okay, now the next one. In the next second step, ammonia and oxygen react to form nitric oxide and water. So here you can see the equation and that will be the del H is equal to negative 905.0 kg. Now you need to calculate the net change in enthalpy for the formation of 1 mole of nitric oxide from nitrogen, hydrogen and oxygen from these reaction, and the second thing, that is round your answer to the nearest kilojoule. So now first of all, that means the equation of the net reactions can be found by adding up the two copies of the equations from the first and here from the first step and one copy of the equation from the second step, like so. Here is nitrogen react with hydrogen to form ammonia, and here you need to balance this, so there will be 2 moles of ammonia and 3 moles of hydrogen that react to form like the ammonia formation. Now the second step, in the second step here you can see that ammonia and oxygen that will combine to form nitric oxide and the water molecules form. So now you need to write the second step, that is NH3 react with oxygen to form NO and H2O. Let me write it again. So here it will be H2O. Now you can see by balancing the equation, so there will be like instead of here will be 4, here is 6, hydrogens are balanced, so now there will be 4 and there will be 5 oxygen. So that is our equations. You can see that is already balanced, that are present in the question as well. Now the next one, you need to equalize themselves. Like here are 2 ammonias, 2 mole of ammonia, and here are 4. So it means you need to multiply the first equation by 2. Okay, so you need to multiply the first equation by 2. It means now there will be let me zoom in, then you can see. Okay, so there will be now 2 times nitrogen, that will be 2 N2 plus 2 times 3 moles of hydrogen, that will equal to 6 H2 plus. Okay, now there are 4 ammonia molecules, so here is 4 NH3 plus 5 oxygen. It will give what? Here is 4 ammonia, 4 NH3 plus 4 NO plus 6 moles of water molecules. Alright, now in this equation, now you can see here 4 NH3 will cancel out by 4 NH3. So now you have the net equation, that is 2N 2 plus 6H2 plus 5O2. It will form 4NO plus 6H2O. Okay, so it means here the first step, that is given del H is equal to negative 92, while the second step, that is del H is equal to negative 905.0 kilojoule. So here you need to check, and you need to notice that the intermediate NH3 cancel out of the net reaction. So Hess law tells you that you can find the net reaction enthalpies by adding up the reaction enthalpies of the steps in exactly the same way. That is, in this case, the net reaction of the enthalpies equal 2 times the reaction enthalpy for the first step. So the first step is minus 92 or negative 92, okay, plus the reaction enthalpies of the second step. So the second step is minus 905 kilojoule. Alright, so both are in kilojoules. Okay, now you need to add up. First, when you multiplied it and then when you add up, so it means the answer will be negative 1089 kilojoule. Okay, so notice that the coefficient of the nitric oxide here, the coefficient of the nitric oxide in the equation of the net reaction is 4, because you can see here that is 4. So that means negative 1089 is actually the net change in the enthalpy for the formation of 4 moles of NO. So you need to find here in the equation, you need to find, or in the question you need to find the formation of 1 mole of nitric oxide. So it means here you need to divide 1089 divided by 4 and you get, so by 4 to get your final answer, and the answer will be negative 272 kilojoule. Okay, so that is your final answer. It means the del H, or change in enthalpy of the 1 mole of nitric oxide, that will be negative 272.0 kilojoules. Okay, so that is your final answer. Okay, so I am going to show you the whole steps. You can see here. Okay, so that is our final answer. So if you like our video, then kindly subscribe us and share our channel. Thank you so much for the watching, and we'll see you in the next video. Goodbye.